Okay, in this video I'm going to show you how to factor, or some say factorize, a cubic expression. We are all familiar with factoring quadratic expression, say minus 2x minus 3, the factored form. So you have two expected factors, x and x, 3 and 1 coming from 3, and then I have to have negative 3 and positive 1. Okay, you can check that, and it should end with x squared minus 2x minus 3 when you multiply these two. Now, as we go higher, the expression can change into a cubic or something with an exponent like 4 or 5. Okay, but in this video, I'm going to stick with one of the specific kind of polynomial. This is a cubic polynomial in which the highest exponent is 3. Okay, so how do we factorize this? Now, in factoring this, we'll be combining the concept of factor theorem, and somehow we use some division, and in this case I'll stick with synthetic division, okay, for a faster division. Okay, so the key in factoring this is that we need to transform this into an expression times an expression times another expression. Okay, the highest possible number of factors that you can have is the exponent of the leading term, which is x cubed. Okay, so how do we find these three factors? Okay, the key in identifying these three factors lies on this number. Okay, now there will be more complicated expression, but in most cases one of the factors can be taken from this number 3. So what do I mean by that? Okay, so what you have to do is to identify the factors of 3. Okay, so it just could be the 1 or the 3, and must be, or maybe rather, so maybe the positive 1 or negative 1, or the positive or the negative 3. So how do we use these numbers? That's where we use a synthetic division. Okay, the synthetic division, okay, is connected to the factor theorem in the sense that when the last entry is a 0, it means the given expression is a factor of the given polynomial. Okay, so let's work on it now. So what we have is the polynomial x cubed minus 3x squared minus x plus 3. So to perform the synthetic division, we get the coefficients. So we have 1, negative 3, negative 1, and 3 coming from this polynomial. And then we have to test positive 1, negative 1, positive and negative 3. Let's start with 1. Okay? So when we perform the synthetic division, remember the goal is that we should end with a 0. If this will end with a 0, then that means x minus 1 is a factor coming from this number. Okay? But we have to test that. Okay? So let's see. Okay, so if I will bring down 1, so this is 1 times 1, so 1, then we add, so this is negative 2, multiply negative 2 to 1, it will give you negative 2, then you add again, negative 3, negative 3 times 1 is negative 3, and if you add it, it will become 0. So we were able to confirm that x minus 1 is one of the factors. Okay, so the solution is almost done. Okay, because we now have, so x cubed minus 3x squared minus x plus 3 is equal to x minus 1 and 2 more factors. So how do we find these 2 more factors? So you have to use the quotient after doing the synthetic division. So this one, negative 2 and negative 3, means x squared minus 2x minus 3. And to find the other factors, you just have to factor this. Okay, and that will be x minus 3 and x plus 1. So the complete factored form of the polynomial is x minus 1. So x minus 1, then you have x minus 3, and you have x plus 1. Okay, so let's just rewrite the final answer. The factored form of x cubed minus 3x squared minus x plus 3 is x minus 1 times x minus 3 times x plus 1. Okay, so we are very lucky that when we tried 1, we ended up with 0 immediately. Sometimes the last number is not a 0. So when this is not 0, that means you have to try the other numbers, negative 1, the positive 3, and the negative 3, until you get 0 in the end. And then you just have to do the same thing, get this number 1, negative 2, and negative 3, and form them as x squared minus 2x minus 3. And then just factor. Okay, so that's how you factor a cubic expression. We use the ideas factor theorem and synthetic division. Okay, so that's it.